Based on the text, how are polarons believed to be involved in the superfluorescence observed in Biliroglu and colleagues' study? In superfluorescence, electrical charges known as dipoles emit light in a synchronized burst so intense that they are visible to the eye. Until recently, this phenomena has only been observed at extremely cold temperatures because dipoles cannot synchronize at higher temperatures. But in a study, Melik Biliroglu and colleagues observed superfluorescence at room temperature in thin films made of perovskite and other similarly crystalline materials. The researchers proposed that the formation of shock-absorbing quasiparticles called polarons in the material protects dipoles from thermal interference. So option choice A says, polarons enable superfluorescent bursts to cross from one crystalline material to another. This is incorrect because the text doesn't suggest this, where the second sentence in the text highlights how superfluorescence was observed at room temperature in thin films made of perovskite and other similarly crystalline materials, and that the formation of shock-absorbing quasiparticles called polarons in these materials protects dipoles from thermal interference. So it's highlighting that the polarons helped allow for dipoles to synchronize, even though that it took place during room temperature. So option choice A, which says that polarons enable superfluorescent bursts to cross from one crystalline material to another, is incorrect, because nowhere in the text does it suggest this. So A is incorrect. B. Polarons allow for the dipoles to synchronize despite higher temperatures. This seems to be the correct answer because the second sentence in the text suggests this, where it highlights how these two materials, perovskite and other similarly crystalline materials, allow for the creation of polarons, and in these materials, superfluorescence is observed because in this material, the material protects dipoles from thermal interference. So it says that polarons allow for the dipoles to synchronize despite higher temperatures. So B seems to be the correct answer. C. Polarons accelerate the dipole's release of superfluorescent bursts. This is incorrect because the text suggests that polarons enable dipoles to have superfluorescence bursts at room temperature, not that they accelerate the release of superfluorescent bursts. So C is incorrect. D. Polarons decrease the intensity of the superfluorescent burst. This is incorrect for the same reason as C is incorrect, because the text suggests that the polarons enable superfluorescent bursts at room temperature, not that they decrease the intensity of the superfluorescent burst. So D is incorrect. The correct answer is B.